Right now, in the deep tropical Atlantic, roughly halfway between the coast of Africa and the islands of the Lesser Antilles, a cluster of thunderstorms has organized itself enough that the National Hurricane Center is giving it an 80% chance of becoming a tropical depression within the next 48 hours. At almost the exact same moment, a second tropical wave is producing disorganized but strengthening storms just south of the Cabo Verde Islands, with forecasters assigning it a 50% chance of development within a week. More than 3,000 miles away, in the central Pacific east-southeast of Hilo, Hawaii, a system has already been designated a potential tropical cyclone with a 90% chance of formation in the next 2 days. And off the coast of Baja California, a brand new tropical depression is spinning in open water at this very hour. 4 separate systems, 3 ocean basins, all being tracked by government meteorologists on the same calendar day. This is not a slow week in the tropics. This is the moment the machine switches on. For most of this summer, the Atlantic has been unusually quiet. As of the second week of August 2026, the basin has produced only 3 named storms all season: Arthur, Bertha, and Cristobal, well behind the pace of an average year. The overall energy released by those storms is running roughly 75% below the long-term average for this point in the calendar. Forecasters at NOAA and Colorado State University have both revised their seasonal outlooks downward, citing a rapidly strengthening El Niño that is increasing the vertical wind shear, tearing apart storms before they can organize. On paper, 2026 looks like it could be one of the quietest Atlantic hurricane seasons in years, but that quiet is about to end, and the reason it is about to end is not speculation. It is written directly into the calendar. Every hurricane season on Earth has a rhythm, and the Atlantic's rhythm has a single, well-documented turning point. Meteorologists call it the climatological peak, and it falls on September 10th, a date calculated from 77 years of storm records stretching back to 1944. More than 85% of all Atlantic tropical cyclones form during August, September, and October. The lull that has defined the season so far tells you almost nothing about what comes next, because the atmosphere itself is about to change beneath our feet. Wind shear, the force that rips storms apart before they can strengthen, is normally strong through the spring and early summer, but it fades steadily through June and July and hits its yearly minimum by mid to late August. At the same time, sea surface temperatures across the tropical Atlantic and the Gulf, which lag behind air temperatures by weeks, finally reach their warmest point of the year. Saharan dust, which suppresses thunderstorm activity earlier in the summer by drying out the atmosphere over the eastern Atlantic, thins out considerably by mid-August, clearing the way for tropical waves rolling off the African coast to organize instead of collapsing. 3 separate atmospheric breaks, all released within the same 3 to 4 week window. That is not a coincidence of timing. That is the engine of hurricane season turning over, and it happens like clockwork every single year, whether the season has been active or silent up to that point. This is exactly the window we are standing in right now, and this year it is arriving with 2 tropical waves already lined up in the Atlantic and 2 more systems already active in the Pacific, all at once. Go back to what the National Hurricane Center is actually reporting on this system moving through the central tropical Atlantic. The wave, designated AL92 in forecaster shorthand, is located roughly midway between the Lesser Antilles and the west coast of Africa. Showers and thunderstorms associated with it have become noticeably better organized over the past day. The environment around it, warm water, low shear, moist mid-level air, is forecast to remain conducive for strengthening over the next day or so, which is why the formation probability sits at 80% through both the 48-hour and 7-day windows, forecaster language, for near certainty that this becomes at least a tropical depression. The complication is what happens after that. As the system tracks westward and then west-northwestward across the central Atlantic, it is forecast to run into a wall of stronger upper-level winds beginning around Friday, right as it nears the Lesser Antilles. That timing matters enormously for anyone living on those islands, because a storm that intensifies quickly before hitting that wall behaves very differently from one that is still weak and disorganized when it does. To put the intensity scale itself in plain terms, because the category numbers get thrown around constantly during storm coverage without much explanation, the Saffir-Simpson scale runs from Category 1, sustained winds of 74 to 95 miles per hour, capable of snapping tree limbs and stripping shingles, up through Category 5, sustained winds above 157 miles per hour, capable of leveling framed homes and rendering entire areas uninhabitable for weeks or months. Each step up that scale roughly quadruples the potential wind damage, according to NOAA's own damage potential assessments, which is why the difference between a storm topping out at Category 1 versus Category 3 is not a modest difference in inconvenience. It is an entirely different disaster with an entirely different recovery timeline. That scaling is exactly why rapid intensification is treated as such a serious forecasting concern. A storm that jumps from Category 1 to Category 4 in a single day, as Hurricane Beryl did in June 2024, does not just get moderately worse. It becomes capable of a category of destruction that most coastal building codes were never designed to withstand, arriving on a timeline that can outpace evacuation planning built around slower, more gradual intensification. Behind that system, a second wave, AL94, sits a few hundred miles south of the Cabo Verde Islands, producing disorganized but persistent shower activity. This is what meteorologists call a classic Cape Verde system, the kind that spawns off the West African coast during the heart of hurricane season and tracks thousands of miles across open ocean, sometimes strengthening the entire way. Forecasters currently give it a 30% chance of development within 48 hours and a 50% chance within 7 days, numbers that will almost certainly climb as the system moves into the warmer, less sheared water expected later this week and into the weekend. Two systems, staged one behind the other, both riding the exact same conveyor belt of tropical waves that defines the Cape Verde hurricane season every single year at this point on the calendar. Meanwhile, over in the Central Pacific, an entirely separate part of the tropical machine is already running. The National Hurricane Center, which also handles Pacific tropical weather forecasting alongside the Central Pacific Hurricane Center in Honolulu, is tracking a system located about 895 miles east-southeast of Hilo, Hawaii, and has already designated it Potential Tropical Cyclone 1C, a formal classification reserved for systems expected to affect land before they technically become a tropical cyclone. The formation chance on this one is 90% through both 48 hours and 7 days, essentially a formality at this point. The only real question is exactly how strong it gets and exactly what path it takes relative to the Hawaiian Islands. Further east, in the eastern Pacific off Mexico, a brand new tropical depression designated 8E has just formed more than 400 miles west of the southern tip of Baja California, out over open water for now, but adding yet another data point to a basin that, unlike the Atlantic, has stayed persistently active all summer. Step back and look at what that means in plain terms. On a single Thursday in the middle of August 2026, meteorologists in Miami and Honolulu are simultaneously monitoring active or imminent tropical development in the central tropical Atlantic, the eastern tropical Atlantic near Cabo Verde, the central Pacific near Hawaii, and the eastern Pacific off Mexico. That is 4 systems at 4 different stages of development, spread across roughly 10,000 miles of ocean, all appearing on forecast maps within the same 24-hour period. Individually, none of these is unusual for mid-August. Together, appearing at exactly the moment the Atlantic's seasonal breaks are being released, they represent something meteorologists have a specific term for: ignition. The tropics are not gradually waking up, they are switching on in multiple places at once. Now go deeper into why a quiet start to the season should not be read as a safe season, because the historical record on this point is not ambiguous, and it centers on one of the most important lessons in modern hurricane history. In 1992, the Atlantic hurricane season was, by every early measure, dead. By mid-August of that year, only a handful of weak, short-lived systems had formed, well behind the pace of a typical year. Forecasters at the National Hurricane Center were openly discussing the lack of a hurricane season with reporters. Then, on August 16, 1992, a tropical wave came off the coast of Africa. It drifted for days, weak and disorganized, drifting between Bermuda and Puerto Rico, with forecasters not expecting much from it. On August 22nd, it encountered a pocket of dramatically reduced wind shear and began to explosively strengthen. 2 days later, on August 24th, it made landfall in South Florida as a Category 5 hurricane with sustained winds of 165 miles per hour, a central pressure of 922 millibars, and a storm surge of 17 feet. Its name was Andrew. By the time the 1992 season ended, only 7 named storms had formed all year, one of the least active seasons of the modern era by storm count. But Hurricane Andrew alone caused 65 deaths, and, at the time, was the costliest natural disaster in United States history, a title it held for years. The lesson meteorologists have repeated ever since, almost word for word, is that El Niño and other suppressing factors can reduce how many storms form in a season, but they do very little to limit how strong any individual storm becomes once it does form. A quiet season needs exactly one storm in the wrong place to become a catastrophic one. It only takes one. That lesson is directly relevant to what is forming in the Atlantic right now because of a second scientific trend that has become impossible to ignore in the last decade. Hurricanes are strengthening faster than they used to, and they are doing it more often. Meteorologists define rapid intensification as an increase in a storm's maximum sustained winds of at least 35 miles per hour within a 24-hour period. Research published in the journal Nature Communications found that between 1982 and 2009, the percentage of Atlantic storms undergoing rapid intensification roughly tripled. More recent studies looking at major hurricanes specifically, meaning Category 3 and above, have found that around 79% of them undergo rapid intensification at some point in their life cycle, and that the proportion of Atlantic hurricanes reaching major hurricane strength has doubled since 1980. The mechanism behind this is not complicated. A tropical cyclone is essentially a heat engine that pulls energy out of warm ocean water and converts it into wind. The warmer and deeper that layer of warm water is, the more fuel is available, and the faster a storm can spin up. Marine heat waves, prolonged stretches of abnormally warm ocean temperatures that have become measurably more frequent as the climate has warmed, have been shown in peer-reviewed research to make rapid intensification roughly 50% more likely in the Gulf of Mexico and the northwestern Caribbean specifically, two of the exact regions any storm crossing the Atlantic this month would eventually have to pass through or near. This is not a theoretical pattern from decades ago. It happened repeatedly in just the last two Atlantic hurricane seasons. In 2024, 7 separate hurricanes underwent rapid intensification, including Beryl, which went from a weak tropical depression to the first Category 4 hurricane ever recorded in the Atlantic Basin during the month of June, in just 48 hours. Milton underwent 2 separate rapid intensification episodes in a single life cycle. At one point, gaining 90 miles per hour of wind speed in about 36 hours, as it crossed waters made hundreds of times more likely to be that warm because of climate change, according to attribution analysis from Climate Central. In 2025, 4 separate storms rapidly intensified, including Hurricane Erin, which exploded from a modest tropical storm into the season's first Category 5 hurricane after gaining 85 miles per hour of wind speed in barely more than a day. What all of this means for the systems currently forming in the Atlantic and the Pacific is simple and worth sitting with for a moment. The ocean water these systems are about to move across is, on average, measurably warmer than it was even 15 years ago. And warmer water does not just mean storms are more likely to strengthen. It means they are more likely to strengthen fast, sometimes with less warning time than coastal communities have historically had to prepare. Go back now to the specific system closest to land, the wave-designated AL92 tracking toward the Lesser Antilles. If the National Hurricane Center's current thinking holds, this system will likely become at least a tropical depression and possibly an organized tropical storm sometime in the next day or two, while it still has open, warm water and low shear working in its favor. The complicating factor is the wall of stronger upper-level winds forecast to move in by Friday as the system nears the islands. If the storm strengthens quickly before it reaches that wind shear, residents across the Lesser Antilles, Puerto Rico, and the northeastern Caribbean could be looking at a tropical storm or even a hurricane approaching within days. If it strengthens more slowly, the shear could tear it apart before it ever reaches land, leaving it as a disorganized rain event rather than a wind event. This is exactly the kind of forecast uncertainty that meteorologists deal with constantly during Cape Verde season, and it is exactly why the National Hurricane Center updates its outlook every 6 hours during active periods like this one, refining formation probabilities, and tracks as fresh satellite and reconnaissance data comes in. Behind AL92, the Cabo Verde wave designated AL94 is earlier in its life cycle, but riding into an increasingly favorable environment. Systems that form near the Cabo Verde Islands in mid to late August have a long history of becoming some of the most dangerous storms of the season, precisely because they have thousands of miles of open, warming Atlantic water ahead of them to intensify over before ever encountering land or significant wind shear. Some of the most destructive hurricanes in Atlantic history, storms whose names remain instantly recognizable years later, began exactly this way, as a modest cluster of thunderstorms a few hundred miles off the West African coast in the second or third week of August. That does not mean AL94 will follow that path. Most tropical waves that form near Cabo Verde do not become major hurricanes. But the setup, geographically and seasonally, is the same setup that has produced historic storms before, and meteorologists watching this wave are aware of that history even as they wait for more data. There's also a broader pattern worth understanding here because it connects everything happening in the Atlantic right now to what is happening simultaneously in the Pacific. Tropical cyclones do not form randomly. They form where 3 specific ingredients align: warm ocean water to at least about 80 degrees Fahrenheit, extending to a meaningful depth, low vertical wind shear that allows a storm structure to build straight up rather than being sheared sideways, and enough atmospheric moisture and instability to sustain the thunderstorm clusters at a system's core. In mid-August, across almost the entire northern hemisphere tropics, all 3 of those ingredients tend to align simultaneously because the underlying driver, the sun's heating of the ocean surface through the long days of the northern hemisphere summer, does not respect ocean basin boundaries. The same seasonal warming that is fueling the Atlantic wind shear minimum and sea surface temperature peak is fueling the same conditions across the central and eastern Pacific at almost exactly the same time. That is precisely why potential tropical cyclone, 1C near Hawaii and Tropical Depression 8E off Baja California are developing in the same window as AL92 and AL94 in the Atlantic. It is not multiple unrelated coincidences. It is one planetary pattern expressing itself in 4 different ocean regions within the same 24 hours, because the underlying physics driving all of them is the same physics, running on the same calendar. The system near Hawaii deserves particular attention precisely because of how rare it is for the islands to face a direct tropical threat at all. Hawaii sits in a part of the Central Pacific, where cooler water and unfavorable wind patterns typically steer most tropical systems well to the south, which is why direct hurricane strikes on the islands remain historically uncommon compared to the Gulf Coast or the Atlantic Seaboard. That relative rarity is exactly what makes a 90% formation probability this close to the islands worth watching closely rather than dismissing. A system that does tracks toward the Big Island or Oahu arrives in a place where building codes, drainage infrastructure, and public experience with tropical storm evacuation are all calibrated for a threat that residents have not had to prepare for nearly as often as their counterparts along the Gulf. Meanwhile, off Mexico's Pacific coast, Tropical Depression 8E is a reminder that the Eastern Pacific Basin, unlike the Atlantic, has not experienced anything close to the same seasonal suppression this year, continuing a pattern of persistent activity that has held throughout the summer even while the Atlantic sat unusually quiet. Andrew was not even the only example of this pattern in modern memories. 9 years earlier, in 1983, the Atlantic produced only 4 named storms all season, one of the least active years on record at the time, largely because a strong El Niño that year was driving the same kind of elevated wind shear currently suppressing this season. Yet one of those 4 storms, Hurricane Alicia, struck the Houston-Galveston area directly as a hurricane, killing more than 20 people and causing well over $1 billion in damage. 2 historically quiet El Niño-suppressed seasons, 4 decades apart, each producing exactly 1 storm capable of overwhelming an American coastline. And in case anyone assumes El Niño years are simply always safe, 2004 stands as the counterexample forecasters point to just as often. That season occurred during a weak, transitional El Niño and still produced 15 named storms, well above the long-term average, because unusually warm Atlantic waters overwhelmed the suppressing effect. Florida was struck by 4 separate hurricanes within 6 weeks that year, causing a combined $62 billion in damage. The pattern that emerges from all 3 of these seasons, 1983, 1992, and 2004, is the same pattern currently unfolding in 2026. Broad seasonal averages describe how many storms are likely to form, but they say almost nothing about what any single one of those storms, once it forms, is capable of doing. Now, consider what a season like this can look like once it fully ignites, using the recent past as the clearest evidence available. Hurricane Idalia in 2023 offers one of the sharpest examples of how quickly conditions can turn dangerous once the seasonal switch flips. Idalia rapidly intensified from a Category 1 storm to a Category 4 hurricane in roughly 24 hours, between August 29th and August 30th, then spent 4 hours over land in Florida as a hurricane, bringing devastating storm surge and widespread destruction. A year later, Hurricane Debbie peaked at a relatively modest Category 1 strength, but still produced 2 to 7 inches of rainfall and gusts up to 70 miles per hour across Florida's Big Bend and into southeastern Georgia, along with storm surge 3 to 5 feet above normally dry ground. A reminder that a storm's category number alone does not tell you how dangerous it will actually be on the ground. Both of those storms formed and struck during the exact same mid to late August window the current systems are forming in now. The practical hazards tied to any storm that does develop out of AL92 or AL94 fall into a few well-understood categories, and understanding them now, before anything makes landfall, is what actually saves lives, not panic after a warning is issued. Storm surge, ocean water pushed inland by a storm's winds, is historically the deadliest hazard associated with landfalling hurricanes in the United States, capable of rising well above normal tide levels within a matter of hours and overwhelming coastal roads and structures with little warning for anyone who has not already evacuated. Wind damage scales dramatically with intensity, which is exactly why rapid intensification is so dangerous from a preparedness standpoint. A storm that jumps 2 categories in a day can outrun the evacuation timelines that coastal counties have built their planning around. And inland flooding from heavy rainfall, particularly from storms that slow down or stall after landfall, a behavior scientists have also linked to a warming atmosphere, has become responsible for a growing share of hurricane-related fatalities in recent years, often striking people who assumed the danger had passed once the wind died down. None of this is a reason for panic, and it is worth being direct about that, because panic leads to bad decisions just as often as complacency does. What the current setup, 2 developing waves in the Atlantic, 2 active systems in the Pacific, arriving exactly as the atmosphere's seasonal breaks release, actually calls for is preparation. The same preparation emergency management agencies have recommended for decades, and that becomes exponentially harder to complete once an actual watch or warning is issued for your specific location. That means having a battery-powered or hand-crank radio and copies of important documents ready before a storm is bearing down on you. It means knowing your evacuation zone if you live anywhere near the coast, because evacuation zones are based on storm surge risk, not on wind category, and many people confuse the two. It means having a plan for where your family will regroup if cell service goes down, because it often does. It means thinking through a backup power option for essential devices, even something as modest as a small battery pack, since extended outages are one of the most common and most underestimated consequences of a landfalling storm, sometimes lasting far longer than the storm itself. And it means securing anything outdoors that could become a projectile in sustained winds well before a watch is ever issued for your area, because that task becomes exponentially harder and far more dangerous to attempt once wind speeds actually start climbing. None of that requires a confirmed hurricane on the map. It requires exactly the kind of advance notice that these current systems, still days away from any potential landfall, are giving anyone paying attention right now. There is one more piece of context worth understanding about how these systems get tracked from this point forward, because it explains why the names attached to storms carry so much weight once they are assigned. Every Atlantic tropical storm is named from a preset alphabetical list maintained by the World Meteorological Organization, rotating on a 6-year cycle, and the only time a name is ever permanently removed from that rotation is when a storm using it caused destruction or death severe enough that reusing the name would be considered insensitive. Andrew was retired. So were Katrina, Harvey, Irma, Maria, Michael, and Ian, among dozens of others. If AL92 organizes into a named storm, whatever name comes next on this year's list, it enters that same system, tracked by the same forecasters, held to the same threshold. Most storms never come close to that threshold. But every storm that reaches it started out exactly the way AL92 and AL94 exist right now, as a loosely organized cluster of thunderstorms with a formation percentage attached to it rather than a name. This is also the point in hurricane season where the value of the forecasting system itself becomes clear. And it is worth taking a moment to actually appreciate what is happening behind the scenes of every one of those percentage figures mentioned earlier. Every formation probability issued by the National Hurricane Center is built from satellite imagery, updated continuously, from Hurricane Hunter aircraft that fly directly into developing systems to measure pressure, wind speed, and structure firsthand, from ocean buoys recording sea surface temperature in real time, and from computer models that run multiple times a day, each one simulating how the atmosphere is likely to evolve over the coming week. None of that existed in anything close to its current form even a generation ago. Storms that once might have caught coastal communities with only hours of warning are now tracked as tropical waves, while they are still thousands of miles from any coastline, sometimes a full week or more before they would ever become a threat to land. The 4 systems mentioned at the start of this, still just waves and depressions scattered across 10,000 miles of ocean, are being watched with a level of precision that simply did not exist for earlier generations, who lived through storms like Andrew with a fraction of the warning time available today. That does not mean every forecast is certain, and it is worth being honest about the limits of what meteorologists can actually say right now. Nobody can tell you today whether AL92 will become a hurricane, a tropical storm, or nothing at all by the time it reaches the Lesser Antilles. Nobody can tell you whether AL94 will follow the classic Cape Verde track toward the Caribbean and the United States, curve harmlessly out to sea well before reaching land, as roughly half of all Cape Verde systems eventually do, or strengthen into something historic. What can be said with confidence? Because it is written into 77 years of climatological data and confirmed by exactly what forecasters are watching on their screens at this moment, is that the Atlantic is entering the most dangerous stretch of its calendar year, that the atmospheric breaks, which have kept this season unusually quiet, are being released right on schedule, and that the ocean water waiting for these systems is warmer, on average, than it has been in most of recorded history, which raises the odds that whatever does develop, develops fast. There's a broader point buried inside all of these individual numbers, one that connects the quiet 3-storm season so far to the historic, catastrophic single storm of 1992. And it is this: a hurricane season is not one continuous story with a predictable arc. It is a long stretch of near silence, punctuated by short windows where the entire system can turn dangerous within days, sometimes within hours. The quiet stretch is not evidence that the danger has passed. It is simply the time before the window opens. Right now, in the middle of August 2026, with wind shear falling to its yearly minimum, sea surface temperatures reaching their peak, Saharan dust clearing out of the eastern Atlantic, and 4 separate systems already active or imminent across 3 ocean basins, that window is opening. The instruments are running, the satellites are watching, the Hurricane Hunter aircraft are fueled and ready. And somewhere in the deep tropical Atlantic right now, or off the coast of Cabo Verde, or east of Hawaii, or west of Baja California, the next chapter of this hurricane season is already being written by wind and warm water, whether or not anyone on land is paying attention yet. If you live anywhere near the Gulf Coast, the Atlantic Seaboard, the Caribbean, or the Hawaiian Islands, this is worth passing along to the people you care about who live in those places too. Not because there is a confirmed threat today, but because the entire value of a forecast like this one is the time it buys people to prepare before the outcome is certain. Preparation now, while these systems are still just waves and depressions scattered across open ocean, costs almost nothing. Preparation after a hurricane warning is issued costs time you may not have. The tropics do not wait for anyone to be ready. They run on their own clock, driven by wind and water and sunlight, the same three forces that have governed this exact stretch of the calendar for as long as anyone has been keeping records. What has changed is not the physics. What has changed is how much warning we now get before it happens, and what we choose to do with it. Every one of the numbers laid out here, the 80%, the 90%, the 75% below average, the 85% of the season still ahead, comes from the same place. Instruments and forecasters working around the clock to turn an unpredictable natural process into something measurable, trackable, and survivable. That work does not stop the storms from forming. It has never been able to do that, and it never will. What it does is buy time, real, usable time, for anyone willing to pay attention before the satellite images turn into headlines. Right now, in the middle of August 2026, with 4 systems already moving across 3 oceans and the calendar itself sliding into the most dangerous stretch of the year, that time is exactly what is on the table. The window will not stay open quietly for long. Whether it opens into nothing more than a few days of rain over open ocean, or into the next name pulled off that list, is being decided right now out over warm water, far from any coastline, by forces that have been running the same seasonal pattern for longer than anyone has been alive to watch it.